Linda Shea with Drilling Contractor. Today I'm at Endeavor Technologies Experience Center in Houston, Texas, where Endeavor and Noble are conducting CO2 drilling simulations. And I have with me Zach Bruton, Senior Business Developer for CCS and Noble, and he's going to tell us about what they're doing today. Thank you for joining me, Zach.
Glad to have you guys out.
So can you tell us about the simulation exercise and what you're hoping to achieve here?
Sure. So right here, we as Noble are actually trying to enable the future of carbon storage. So in our fight for climate change, CCS, or carbon capture and storage, is going to be one of our greatest tools in our tool belt. But what that future looks like is you're looking at millions of tons of carbon being captured at industrial sites, and a large section of that's going to actually be stored offshore in like federal and like state waters. We project anywhere from like 25 to potentially 50% of that carbon, and we're talking millions of tons. What that future looks like is what we're trying to work out here. So as Noble, we own a bunch of drilling assets and like rigs. We're planning for a future now of what that looks like and what they need to do to help these carbon storage sites come online and then throughout their life.
And can you tell us a little bit more about the well control aspects of what you're doing today?
Yes. One of the greatest challenges with CO2 in comparison to like traditional hydrocarbons is that CO2 acts very differently downhole than like methanes or whatever else you're working with. One of the key differences is that it's far more soluble than a methane. So it's going to be a much stickier in your drilling fluid. It's going to be a lot harder to detect, as well as it circulates, it's going to behave very differently. And that's why we're here today. We have drillers offshore. We have a couple different operators and classification societies to work through those problems and to see what this looks like downhole.
So it sounds like there may be a need for some kind of industry standard certification for CO2 rigs in the future.
Yes, we definitely envision that future. That's why we've been partnering with DNV for the past year to do a technology qualification to see what this looks like. And we do believe in the future we'll eventually need these type of rigs that can handle CO2 downhole, can be prepared for it if it does hit our topsides, and then be classified for that service.
Can you talk about any specific learnings maybe you've achieved today, or maybe learnings that you hope to achieve?
So one of the unique challenges too for CO2 is if it does reach the top side is that it's actually heavier than air as compared to methane. So traditionally when you do like a leak and you wanted to just spin that out, you would just eject that from the top of the derrick. You can't do that with CO2 because the CO2 is actually going to settle on the drilling rig itself. So one of the key lessons that we've learned is we've actually designed new vent lines and ventilation systems to enable the safety of our personnel offshore.
Well, thank you so much, Zach, for telling us about what you're doing today. It sounds like it's very exciting work and coming to the forefront as we look at CO2 in our industry.
Yeah. Well, thanks for being here, Linda. And I want to thank the IADC for taking a moment to be with us. So thanks.
And thank you for joining us on drillingcontractor.org.